Namaste Coders, I hope you are fine. So today is 26th March and we have already solved today's problem of the day. So you can check out that video in my playlist of problem of the day. Link is given in the description box. And also this video is a part of LeetCode 75 playlist in which we are gonna solve these 75 questions, which are the most important 75 questions as coding interview with 75 questions. So these are the most important 75 questions of LeetCode which will probably come into your interviews. So let's begin with the second problem of intervals. Actually, we have already solved the first problem till monotonic stack, and now we are on the path of solving the second problem. And the, and the problem is, actually I have just tried to solve this problem and yeah, I got some better solution. Yeah. So the problem is minimum number of arrows to burst balloons, right? So there are some spherical balloons tapped onto a flat wall that represents xy plane, right? So this is a long question, right? Let me explain to you in a very short. So before explaining to the problem, one more thing, that I have created a WhatsApp group for the coders. The link is given in the description box, right? So if you have any doubt, if you want to connect with the different coders of the world, you can join the WhatsApp group. That's completely free. So I suggest you all to join the WhatsApp group, right? So okay, so the problem is we have given these range intervals, right? And it is stated that this is x start, this is x end, and we'll throw a arrow, right? And if at any x, and if arrow uh, will be present in this range, this balloon will got burst, right? Similarly, we have to throw an arrow which will be like in this range 2 to 8, so as to burst this arrow, this balloon. So our target is to burst all the balloons in the minimum number of arrows, right? So let's just plot these. There is a balloon with range 2 to 8. There is a balloon with range, this is 1 1 2, let's say 6. And there is a balloon with the range 10 to 16. And there is a balloon with the range, this is 8, right? So 7 to 12, right? So how many arrows we need to burst all these balloons? 2 right now, right? First like this and second like this. So these 2 arrows is needed to burst all the balloons. So answer is 2. Similarly, in this case, right, there is a balloon between 1s to 2. There is a balloon between 3 to 4, 5 to 6, and 7 to 8. So these are 4 different balloons. So we will need 4 arrows. For third case, 1 2, so there is these balloons, right? 1 2 2 3 3 4 4 5. So one balloon will go like this and burst these 2 balloons, and one arrow will go like this and like this, exactly intersecting point, and burst these balloons. So answer is 2. So this is the problem which is given to us, and we have to solve the problem. So we will gonna solve this problem in 3 steps. First, we will discuss the details, which we have already done. Then we will try to solve the problem in native approach, right? Native approach. Then we will optimize that native approach to get the most optimized solution. So this is a typical intersection problem. What is the intersection? So whenever we are given a range and we have to work on those range, those are called intersections, and there are multiple problems which are based on the intersection. So I have already solved few problems based on the intersection. So if you are interested in this topic, you can check out those videos as well. So this is the typical intersection problem, in which we have to find what is given, what is needed, and how can we do that. So Okay, so let's take an example like this, right? What we'll do, so let's plot this out. A balloon between 1 and 6, a balloon with 2 and 8, a balloon with 7 and 12, and a balloon with 10 and 16. So can we do something to find that? Okay, we can burst these two balloons in a single arrow and these two balloons in a single arrow. So there is a common thing between them. So yes, there is a common thing that its end is after this start. So this is a start point of something, a start x. This is end of, let's say, x minus 1. Okay, so what we'll do is we will sort all the given intervals based on their ending points, right? Because that's what we need. We don't need the starting points, we need the ending points, right? So learn this, that if we need to merge the intervals, right, we'll work on the starting points, and if we need to find the common between the intervals, something like that, we need to work on the ending of the intervals, right? Okay, so what we are doing is we are sorting on the basis of ending point, and for working on this, okay, what we'll do, we'll take this this number, which is this point, and we'll check how many intervals which have their start before this point, right? So there is one interval, so we'll ignore this interval, like we can work on that. So, okay, so my what I mean is, if I pass a arrow through this point, how many balloons I can burst? So I can burst one balloon, two balloons, one is this and one is this. So I have burst these two balloons, so I don't have to work on these, right? I will pass this also because this has got burst. Then I have this balloon, so I take this end point and check how many balloons I can burst. So all those starts, right, all those starts which came before this, I can burst those, right? Remaining, I mean, I can burst these. Okay, and how do we do this in linear time complexity, this operation, right? First of all, we have to sort those intervals, so that will be done in log n time complexity and log n time complexity. Let's say this is the case. Okay, these are two balloons, these are three balloons, and then we have this balloon, then we have this balloon, so and then we have this balloon, then we have this balloon. So these are some ending points, and we will sort our array based on the ending points, and we'll take the end of the first element, and okay, then we'll go to the next ending point, right? Then go to the next element. The next element will be this, because this end is coming just after this, right? So I will check that if this end, okay, so if the start of this balloon is before this end, so yes, the start of this balloon is before this end, so I can burst this. So I will pass this and go for the next end. So this end, right? So the start of this end is also before this end. So the start of this balloon is before this end, so I can burst this also using the same arrow, right? Then this end is coming before this end is coming just after this end, so start of this balloon is also coming before this end, so I will burst this. So these four balloons I can burst using single arrow, right? Now come to this is the ending point, and the start is after this end, so I have to use another array. So my array count is now 2, and my current end is become this, right? So I have to work on this end. Okay, now go for the another end, next element. So then for the next balloon, my starting point is before this end, so I can burst this balloon. For the next balloon, right, my starting point is before this end, right? So I can burst this balloon also. And for the next balloon, my starting point is after this, so I can burst these balloons using second arrow. Now this starting point is after this end, so I cannot burst this balloon using this arrow, right? So what I will do, I will use third arrow. So the answer for such a case will be 3. So I hope you understand what I'm trying to say. Okay, so I have written the code of the same. Let's go to the code. So this is a comparison method to compare a vector. So I am comparing the second element, right? So that's why I have to make a comparison vector, comparison function. So I'm sorting the points based on this comparison based on the endpoints, right? Then I'm traveling through all the points, right? I'm taking my answer equals to 1 because I am using first arrow to cater the first balloon, right? The current end is the ending point of the first balloon. Then if the starting point of the iterative balloon is greater than the current end, that means we have to use another arrow. So the answer will get plus plus. So that means we have to use the another arrow, and the current end will become the end of that balloon, right? So this is the case. So the current end will become end of this balloon, right? Okay, so that's it in this code. I will written the answer and we got the solution, right? So yeah guys, this is all in this code. I hope you understand this well. If you have any doubt or anything, any suggestion for me, you can share those things directly in the comment section, or else you can join the WhatsApp group in which we can discuss anything. So that's all guys. I hope you understand this well, and I also hope that you have a nice day. So thank you for watching this video.